Hello, this video we are going to graph 6 functions which you need to become familiar with. The first one is a linear equation. We need to graph the function by plotting 3 points and state the domain and the range. So we can start by graphing the y-intercept, which is 3. The slope is 1/2, so up 1/2. And graph the line. The domain will be all real numbers, negative infinity to infinity. And the range will also be all real numbers, negative infinity to infinity. So 1b is we want to graph another linear equation. And this time the slope is negative 1/2. So we'll go to the y-intercept of 0, 3. And the slope is negative 1/2. So I will go down 1, right 2. I could have also gone up 1, left 2. We wanted to graph 3 points and then graph the line. The domain is all real numbers, negative infinity to infinity, and the range is all numbers as well, negative infinity to positive infinity. The second graph we're going to take a look at is an x squared graph. And we're going to graph this by plotting points. So we can just make a t-table and substitute numbers in for x and y. You want to look at your graph because you have to plot the points on the graph that you're given. So I suggest we plug in -2, -1, 0, 1, and 2. And if we square those are our y values. And now we will plot the points. And we could plot 3 and -3 because we have those values on our graph. But this is a parabola. It should be a nice U-shaped graph. And the domain will be all real numbers. And I'm going to write that on the worksheet after I graph 2b. 2b, we have x squared plus 3. So I'm going to select -2, -1, 0, 1, 2. Plug it into x squared and add 3. Well, I can use 2a. All I really need to do is add 3 to each of those values. And we'll plot the points. And x squared is a U-shaped graph. It's called a parabola. And now we can use the graphs to state the domain and range. The domain are all real numbers for both of them. There are no restrictions on the input values. The range is from 0 to infinity. The lowest or the smallest y value is 0. And then on 2b, the green graph, we can see that the range is from 3 to infinity. So that is an x squared graph. Now let's look at a square root graph. So we know the domain of a square root graph is we need to set the radicand greater than or equal to 0. So that tells us that the points we should pick should start at 0. And since we're going to take the square root, we should use values for x that are perfect squares. So 0, 1, and 4. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And then we'll plot those points. I can also take the square root of 9, because that is 3. And then connect the dots. And the domain is 0 to infinity. Domain are the valid inputs, the valid numbers that you can plug into x and take the square root of. So they have to be positive. So 3b, let's find the domain. Let's take the radicand, set it greater than or equal to 0. X is greater than or equal to 3. So we should graph starting at x values of 3. And then I can substitute in 4 and 7. Why those values? Because 3 minus 3 is 0, and the square root of 0 is 0. 4 minus 3 is 1, the square root of 1 is 1. And 7 minus 3 is 4, and the square root of 4 is 2. So we'll graph those points. And hopefully you can tell it's the same shape. It's just been moved over. The domain of this particular graph starts at 3 and goes to infinity. And the range of the purple graph is from 0 to infinity. And the same for the pink graph. And what you want to be sure you know is the shape of each graph. We have a linear, we did an x squared, and now a square root. The fourth graph is an x cubed. What does an x cubed graph look like? Well, let's substitute in some points to find out. Let's use -2, -1, 0, 1, 2. We're going to cube each of those. -2 cubed is -8. And let's graph them. So an x cubed sort of looks like that. And you might notice just by looking at the graph that the range and domain are both all real numbers. Well, let's see what happens on 4b, where we have x cubed minus 2. I'm going to pick the same values for x. I will cube each of them and subtract 2. So I could really use 4a to help me out. I'm just going to take negative 8 minus 2, negative 10, negative 1 minus 2, or you can just plug it in and calculate it that way. And now I'll graph those points. And you can see that this graph looks just like 4a, except it has been moved down 2. But all we're trying to get you to understand here are the shape of these graphs. So let me go ahead and write the range and domain. So both of these are all real numbers. There are no restrictions. All inputs are valid, as well as outputs. All right, number 5 is a cubed root. So we just did x cubed. Let's look at the cubed root. So we'll substitute in numbers for x. We want to select numbers that are perfect cubes. So let's select negative 8, negative 1, 0, 1, and 8. The cubed root of 8 is negative 2. And let's graph those points. And I hope you see some similarities between x cubed and the cubed root of x. Looking at this graph, the domain and range are both all real numbers. So let's see what happens when we take the cubed root of x minus 2. And on all of my tables, I've been writing xy, but y can always be replaced by the function's name. So I could have put r of x up here. So negative 6, 1, 2, 3, and 10. How did I select those values? Because negative 6 minus 2 is negative 8, and the cubed root of negative 8 is negative 2. 1 minus 2 is negative 1. The cubed root of negative 1 is negative 1. 2 minus 2 is 0. The cubed root of 0 is 0. And so on. And now I'll plot the points. And hopefully you see some similarities between the two graphs. 5a And in this case, all of the A graphs are what we call the parent function. It's the function in standard form. And the B graph, we've moved it. So in this case, 5B, we've taken the graph of 5A and moved it 2 units to the right. But what's important here is the shape of the graph, and that you're graphing these by making a table of values. So I'm not sure what happened to my domain and range here, but the domain for both of these is all real numbers. And finally, graph number 6 is an absolute value graph. So we'll make a table of values. Going to get carried away there. I'm going to do a whole bunch of them. But the absolute value of -5 is 5. And if we graph these, and I'm putting more dots on my graph than I made on my table, an absolute value graph is a V, has a sharp turn. X squared is a U. Absolute value is a V. So the domain will be all real numbers. No restrictions on the domain. But we can see that the range is from 0 to infinity. But I want to go ahead and do 6b. We know it's an absolute value. We know the graph is going to be a V. So we'll start at 2. 2 minus 4 is 2, the -2. The absolute value of -2 is +2, and so on. And if I graph this, you can probably see the pattern. And we just need to make sure you understand that the absolute value graph is a V. And now I'll scroll on down and get the domain and range. So the domain is all real numbers. And in both cases, looking at the graph, the range is from 0 to infinity. And that's all I have for this video. Be sure to contact your instructor for any questions you might have. Look forward to seeing you in our next video. See ya.